Welcome to episode 58 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data and AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Industry 4.0 is no longer a buzzword. It's real, and it's transforming factories around the world into smart, interconnected hubs of innovation.
Absolutely, Jonas. AI is revolutionizing manufacturing with robots, predictive maintenance, and the Internet of Things. It's where data meets the factory floor, changing how things get made.
Let's start with a bit of background. Industry 4.0 refers to the fourth industrial revolution, a shift towards automation and data exchange in manufacturing technologies. It builds on cyber-physical systems, IoT, and cloud computing to create smart factories.
Right, and this shift isn't just about putting robots on the line. It's about connecting machines, sensors, and data streams to make production smarter and more flexible. For example, a car manufacturer might use AI to track parts as they move through assembly, spotting bottlenecks before they become delays.
Exactly. At the core, you have three key components: robots, predictive maintenance, and IoT devices. Robots handle repetitive or dangerous tasks. Predictive maintenance uses data and AI models to foresee equipment failures before they happen. And IoT connects everything, streaming continuous data to centralized systems.
I love predictive maintenance because it's one of the clearest ways AI saves money in manufacturing. Instead of fixing machinery after it breaks, which is costly and unpredictable, companies use sensors to monitor vibration, temperature, or sound. AI models analyze this data and alert maintenance teams when something is off.
That's a great point. Predictive maintenance is a classic example of supervised machine learning in action. Historical sensor data is labeled with failure or normal states. The AI learns to recognize patterns that predict breakdowns, resulting in fewer unplanned stoppages.
And in practice, it can be a game changer. I worked with a large automotive supplier recently. They had a fleet of robotic arms on their assembly line. Using AI-powered predictive maintenance, they reduced unexpected downtime by nearly 50%, saving millions of dollars annually.
Impressive. Now, while robots have been part of manufacturing for decades, their AI-powered evolution is fascinating. Early industrial robots followed pre-programmed instructions. Now, many use computer vision and reinforcement learning to adapt in real time.
Yes, and that shift towards smarter robots opens up a lot of new possibilities. For example, in electronics manufacturing, robots equipped with cameras inspect tiny components at a speed and accuracy humans can't match. They catch defects immediately, preventing faulty products from reaching customers.
That's the intersection of AI and quality control. Using machine learning for image recognition, robots classify defects on thousands of units per hour. The continuous feedback loop improves product quality and manufacturing efficiency.
Another exciting application is in materials handling. Autonomous mobile robots navigate factory floors to transport parts between workstations. They rely on AI algorithms for path planning and obstacle avoidance, making the whole supply chain more flexible.
Autonomous mobile robots highlight the importance of real-time data processing and edge computing. Factories often generate huge quantities of data from sensors and machines. AI models running close to the source can make rapid decisions without latency issues.
Speaking of data, IoT is really the backbone here. Sensors on machines track everything: temperatures, speed, pressure. This massive data flow fuels AI models that optimize operations. For instance, IoT sensors can detect when a conveyor belt is slowing down unexpectedly, triggering an inspection.
Precisely. IoT enables digital twins, virtual replicas of physical assets. These twins simulate performance and predict outcomes under different conditions, helping engineers make data-driven decisions about maintenance, load balancing, or upgrades.
That's right, Jonas. And in a recent consulting project with a food packaging company, they used digital twins to simulate line speed changes without risking actual production time. It allowed them to test new configurations quickly and implement the most efficient setup.
The ability to use AI alongside simulation is transforming manufacturing agility. Factories can respond faster to changes in demand, reduce waste, and improve energy efficiency.
On the flip side, there are challenges. Integrating old equipment with new AI systems isn't always plug and play. Data quality can be inconsistent, and some companies struggle with change management, getting workers and leadership on board.
That's true. The success of AI in manufacturing heavily depends on the quality and consistency of data. Garbage in, garbage out remains a fundamental concern. Without accurate data, predictive models lose reliability.
Also, cybersecurity becomes more critical as factories open up their networks. IoT devices can be weak points for hackers, so secure protocols and monitoring are essential.
To summarize the theory, Industry 4.0 combines robotics, IoT, and AI-driven analytics to make factories smarter, more efficient, and more adaptable. Predictive maintenance and digital twins are key pillars, relying on continuous streams of sensor data.
And from the business perspective, companies adopting these technologies see major benefits: less downtime, higher quality, more flexibility, and ultimately a stronger competitive edge. But it takes thoughtful planning, investment in data infrastructure, and a culture ready to embrace change.
Before we wrap up, Amy, do you have a favorite real-world success story that captures AI's impact on manufacturing?
Absolutely. One of my favorites is an aerospace company that uses AI-powered robots to assemble complex components. They combine 3D scanning with machine learning to handle variations in parts and ensure perfect fits. This drastically cuts assembly time and reduces costly rework.
That's a brilliant example. It shows how AI goes beyond automation to create intelligent processes that adapt and improve.
So true. Well, Jonas, let's share our key takeaways for today.
AI in manufacturing isn't just about more machines, it's about smarter machines connected by data. Predictive maintenance and IoT drive efficiency, while robots using AI improve precision and safety.
And from the front line, implementing these technologies delivers real savings and agility when done right. But companies need to invest in quality data, infrastructure, and people to unlock these benefits. It's an exciting journey, not just a destination.
In our next episode, we'll switch gears and explore AI in sports, looking at how data powers athlete performance and fan engagement.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We love hearing from you, so send your comments or questions. You might even hear them featured in upcoming episodes. Until tomorrow, stay curious, stay data-driven.